Alrighty, on this lesson, what I kind of want to talk about is negative exponents, and I want to take a look at zero exponents and other exponents as we get going. Okay, so well, the important thing we have to realize is this: whenever we do division, think of a division of powers as when you have x to the third over x to the second. Okay, when you divide, we establish that you subtract the powers. 3 minus 2 is just x, okay? We proved it through x's canceling out, right? Well, one of the important things is if you subtract, sometimes the minuend and the subtractant are equal. In other words, what you subtract from one another are the same. Okay? Think if I change it to 3. Well, you get x to the 0 here, right? And if you subtract and get 0, you get an important thing, that anything raised to the 0 power is 1, okay? And just like there, if I do this through the subtraction, it's x to the a over x to the a. Oops. Let's see. Okay. Hello. There we go. If you look at it, it's just telling you this. If you do this, you would do and subtract them, right? A minus a, which is x to the 0. Well, if you look at it, the old expand and cancel, how many x's you have? You have a of them. On the bottom, you have how many of them? You have a of them. Well, when you start dividing them off, what's going to happen is they're all going to cancel. When you divide, x divided by x, it's 1, then 1, then 1, then 1. When you keep multiplying 1, you're going to get 1. So x to the 0 better be the same, because these are the two same things at the end, and that's going to be 1. Okay? So, I have 3 examples here. X to the third divided by x to the third. It's 3 minus 3, which is 0, and anything to the 0 power is 1. This is m to the 25th minus 25, which is m to the 0, and anything to the 0 power is 1. Even numbers, you do subtraction. 31 minus 31 equals 0, and that's 1. Okay. However, if what you are subtracting is bigger than what you have, you get a negative difference, or a negative exponent. And whenever that happens, you got to think reciprocal. Okay, I know it sounds weird, but when you have a negative exponent, you got to think reciprocal. Anything raised to a negative power is the reciprocal. Reciprocal of the expression. Right? Reciprocal. You're going to flip it. Right? So, here's an example of x squared over x to the fourth. Right? If you do it the old-fashioned way, the x's cancel out, you get 1 over x squared. Well, if I take the difference, you get x to the negative 2. Well, these two better be the same then, right? Notice the reciprocal of this, it's like x over 1, negative 2, so that flips, right? Think of it that way, okay? All our rules still apply, okay? So remember, when you multiply, you add exponents if they have the same basis. 5 plus a negative 3 is the same as 5 minus 3, which is 2. And x to the fourth divided by x to the negative 2 is 4 minus negative 2 because of power divided by power subtraction. And 2 minuses make a plus, so 4 plus 2, which is 6. If you want to think of it, it's what you got to do is x to the fourth over x to the negative 2. Right. Well, this is on the bottom. The reciprocal of this is what we're really looking at. And that's to go back upstairs. And if you move it upstairs, that because of the positive, that's x to the 6. Right? If you have a power to a power, just multiply. And just an FYI, you might see it as 1 over x to the 6. Okay? Alright, so let's take a look and operate some of these. Now, you can think of it in 2 ways. You either distribute it first if you can. Remember, you can only distribute a power if it's all multiplied or divided. You can't do it in adding and subtracting. Or you can take care of the negative power first. Okay. The idea is you can flip it first and get rid of the negative. Remember, the reciprocate and flip I'm going to use a lot. All right. So with the first one, I can flip first to take care of that negative symbol. So the reciprocal of 1 over m squared is m squared. Well, if I flip it, that gets rid of the negative and makes it 3, which is just m to the 6th. The other way you can do it is distribute it. 1 to the negative third over m to the negative 6. Now, this is just 1. And then you reciprocate the bottom, which moves it back upstairs. Okay? The reason we can do it in either order is because you can separate this as 1 over m to the second to the negative 1 times 3, right? So you can reorder it that way, or you can flip those orders because multiplication is commutative. So the order in this one's commutative, actually. Okay. Over here, if we look, I'm going to flip first because I want to take care of that negative. So it's now just 2 to the third, and it's still cubed, which is just 2 to the sixth, which is 64, my favorite number. Right. You could have distributed it, and you would have had 1 over 2 to the negative 6 and flipped it again. The next one, oh, that's some homework, and a triangle, and surface area, there we go. There it is. Over here, if we take a look, this whole thing is raised to the 0 power. Well, anything raised to the 0 power is 1. This is the whole thing. You would actually distribute it to every number there, and you would get 0, 1 to the 0, 25 to the 0, and x to the 0, and this is 1, and this is 1, and this is 1, which is 1. Okay? But the whole thing to the 0 power is 1. But this is an interesting one here. This one, I always like to take care of the negative first, because negative just tells you to flip. So it's really the opposite, or the reciprocal of 3/5, which is 5/3 to the third. Okay. Notice how the flipping gets rid of the negative, and now each of those gets the 3. 5 to the third is 125. 3 to the third is 27. Okay. Now this one, you could flip first, or you can distribute. And if you notice, you distribute. A negative times a negative is a positive, so I'm just going to distribute. So if I distribute that, it's m to the third, n squared, and that's it. If you flipped first, it would look like n to the negative 2 or m to the negative third. Then you have to reciprocate those, and they flip flop. Okay. The last one takes a little more work. Let's see if we can do that. Which way matters? Not much. I'm going to flip first, just because it's easier. So if I flip it, it does not change the signs or anything, flipping it. But it just gets rid of the negative here, so it's cubed. So now I got to distribute that 3 to all the terms here. And that's 3 cubed. Y to the negative 2 to the third is y to the negative 6th. 4 to the third, x to the 6th. A lot of times you're going to see me ask for no negative exponents, so that thing actually needs to move back downstairs. 3 cubed is 27 on the top. 4 cubed is 64 on the bottom. X to the 6th. Because this was y to the negative 6 upstairs, it goes back downstairs as y to the 6th. One of the other things we have to be careful of is when you encounter a negative exponent, ask yourself what is being raised to the 0 of the negative exponent, okay? This is the whole object right there. All right, you can distribute it to every piece. 3 to the 0 is 1. A to the 0 is 1. The whole thing is 1. Over here, this tells me to flip first. And now square it, which is 1 over 25m squared. Look at the slight difference. This is a to the 0, which is 1. There's a 3 there, which is just 3. Notice the parentheses there, no parentheses there. Big difference. Make sure you be careful of it. Parentheses mean a lot here. Because this tells me to do power first, then multiply. Order of operations. Just like over here, this is the only thing getting raised to the negative 2. So it's 5 over a squared. That's all you can do. Over here, we can just flip if we wanted to. It's 1 over a squared flipped is a squared over 1, which is just a squared. Gets rid of it, which is a to the 4th. All right. The last operation you can do is actually put numbers in. You might see me write f of x, or f of 4 in this case if I give you it as an f function. 3 times 4 to the 0 plus 4 to the negative 2. Anything to the 0 power is 1, so this is 3 times 1, which is 3. Plus, that is 1 over 4 squared, which is 3 plus 1 over 16, which is 16, 32, 48, 49 over 16. Okay? So there's a lot more we can do. If we do f of 2, see, there's your example of it. What you're going to have is 3 times 2 to the negative 2. Make sure you just do that, which is 1 over 2 squared, which is just 1/4. 3 times 1/4 is 3/4. Okay? See how I flipped it? Squared each term, and I still have the 3 there. Alright, here we go. If I have 3 times, yeah, that's an e, that's not a 6. 6 to the negative 1 plus 3 times 6 to the negative 1. You can see the huge difference the parentheses make. This is the only thing getting reciprocated, so this is 3 times 1 over 6. Well, this one is the whole thing reciprocated, which is 1 over 3 times 6, which is, if you notice, 1/2 plus 1 over 18. All right, which makes a big difference because this is 9 over 18, so that's 10 over 18, and it's 5 over 9. Okay. The last expressions we can have is write it without a denominator. So if I want to write it with no denominator, I can move things up by putting it as a negative exponent. So 2c squared, I can move this up by writing it as a to the negative third. Notice how if I were to go and use it, it would become negative. Well, I can write this one upstairs too, which is just the reciprocal, which is just the opposite, which is the negative of a negative, which is a positive, which is c squared. Well, I can combine those and I can get 2c to the fourth, a to the negative third. My denominator's gone. Notice if I subtracted those two, could I have done that? It's 2 minus negative 2, which gives me the 4, so it would have done that too. The other option is when people ask to write it with no negative exponents, so write it using only positive exponents. Whenever you see a negative, just reciprocate. If it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. So you can write it as 5. That only has no power, so that stays on top. The x to the negative fourth goes downstairs, so a positive 4. And then the y squared is up there. Okay? Practice makes perfect with these, so be careful and take your time.